Now I'll invite Sumant to give you a run through of our models. He'll explain how to use these models, how to download them, how to deploy them, how to use them from our public interfaces, and how to even fine tune them if you have domain specific data. So I'll hand it over to him. Thank you.
We have a demo notebook, and if you want to, you can actually follow us live. If you have laptops, if you want to try it out with me, that's also fine. Otherwise, also you can find our notebooks on our GitHub repository. You can go to Google, search IndicTrans GitHub, you'll find it, and there's a big link highlighted on the README itself. You should be able to follow through. So in this workshop, I want to basically show you how to use our models, how to train our models, and how to train and fine tune on top of our models as well. So again, in terms of usage, I want to cater to all the people that are there here. So many people are just used to GUI way of using it. We have that as well. Some people want to hit an API, or software engineers, we have that. And there'll be tech people who want to actually run code and get inferences. We also have that. So today I want to give you all the different ways that you can use our models, and also train if you want to with your own data, or reproduce our results with our data. Yeah, I'll just get started. We'll run some basic imports, and then here are all the 11 languages that we support: Assamese, Bengali, Gujarati, Hindi, Kannada, Malayalam, Marathi, Odia, Punjabi, Tamil, and Telugu. So this is the currently hosted URI, which we can hit and get inferences. So there are, again, this is for mostly software and API kind of people who want to just hit an API with a sentence with the source and target language, and they should be able to do it. So here the text that you're passing to the model is: the goal of AI for Bharat is to build language technologies for all Indian languages, and we're translating this from English to Hindi. Yeah, this is the translation. Anybody who wants to take a dig at reading it and make sure that there are no mistakes? We can try a couple of examples, different languages. Yeah, if you, I can take input from the audience as well. If you want to try a complex sentence, we'd be happy to look at how the model is performing. Do you want to try only Google Trans? Why not IndicTrans? Okay, let's go to, I'll show you another tool where you can access. So this is Ulka that we have been talking in the morning. So we have our tools hosted on Ulka as well. So if you go to Ulka and then translation, we want to do English to Punjabi first. The main theme here is, first thing, we have a hosted URI. If you want to try it out by hitting the API, that is one way. And like the other option here, we also have it hosted on Ulka. There's also a third option where you can go to Hugging Face. Software engineers, where they want to. You can use the GUI as well. So you can use it. So, I mean, you can use Ulka. Or there is one more place where you can do this. So there are our models hosted on Hugging Face as well. This is also a simple GUI where you can input and get outputs for all the 11 languages. There's a drop down where you can select and run the appropriate language that you want to. Meanwhile this loads, I'll just go over the next set of things. So basically this again an extension of the previous thing. Where we were running only single sentence. Now we'll just run a batch of sentences. This again mostly for software engineers, because we get batches of sentences. We can translate paragraphs at the same time. We basically break it into sentences and send a whole batch, and we get batch translated at the same time. But the other thing that I want you to look at is the speed at which this is happening. The first one sentence input we are getting in like a 0.1 second. Similarly here we are getting these outputs very fast, so there's no model inference time that they're looking at, so it's almost instantaneous. Yeah, now this is also back, and this is also very simple. You can input anything in English and get all the outputs for all the languages, 11 languages that we support here. So these are GUI based, and the mostly software engineering side of how to use our current models. So this is that part. Next we'll go to the code side of things. So how do you run it via code, where you take our models, download those checkpoints, load the weights, and do something on top of it. So these are a bunch of installations that I'm doing, and these are completely reproducible if you're running. I'm hoping the person following going with me. Okay, cool, no issues. Yeah, these are these few cells are a bunch of installations that we're doing which are required to run the model. We are just checking that we are running on a GPU system, because these are fairly large models that require GPU to get fast inference. So here we are using a Tesla T4 with 16 GB RAM, and this should be able to serve our needs. Yeah. While this installation happens, do we want to try some more inputs from the audience? It'll take a couple of minutes to install this. We can try to be adventurous. There's nothing wrong. We saw bad outputs. That's completely fine. That's where we know we have to improve. Indic to English. Yeah. Also, just to be a little more adventurous, let's see what Google gives for the same thing. We'll see if you're better than them or not. Okay. Is this correct in Marathi? Like, is this translation correct? Yeah.
Is the translation? Yes,
It is correct? Okay.
just for it says meeting instead of a meet.
Okay.
That's it. The rest is okay.
Okay. Let's see if we are able to get Indic to English. No, this is Hugging Face. Okay, yes, there was a phone call from him, but I told him that we did not have time. Is this the same thing? Okay, he missing the meeting. Got it. Okay. Yeah. Yeah, that one made it a meeting and we missed the meeting. Both of us are not correct. Just a couple of minutes. This generally takes a little while to get the whole system up and running. So here we are running training and doing inference using FairSec API. FairSec is a tool from Facebook people where it allows us to train and run inference on models. So we use their library to train our models and basically build our innovations on top of it. Again, I'll just quickly go over what happens when we're actually training or running inference. The first thing is we curate a large set of data, then we do script mapping. We can also take an example of script mapping once these cells get loaded. So we can show you a bunch of examples where we take any sentence input in Indian languages and do a script mapping them to Devanagari and see if you're losing or if it's making any mistakes. That's also one thing we could do. Now the models are loaded. We're downloading the models. So one more thing is that currently we'll be demoing Indic languages to English and English to Indic languages, but there is also an Indic to Indic language where you can translate from any of the 11 Indian languages to any of the other 11 Indian languages. This model is also available currently open source. You should be able to download it. Because we have some time constraint, I have commented this part of the code out, but you should be able to use the same set of notebook and same set of instructions and translate between any two Indian languages as well. Everything that you see here is available on Ulka, even the data sets, the models, everything. I'll just quickly show you the next set of examples that I'll be trying. Two of them are short sentences which are fairly straightforward. One is a slightly longer sentence and it has some technical terms as well, like say COVID-19. It's a scientific term to some extent, and at the time that we were crawling and creating this data, this was a project towards the end of 2020. So we had probably seen COVID-19, but not to a large extent, given that we have crawled and curated data for the last 10 years. So in the scale of 10 years, maybe 6-7 months, probably we have seen some articles which had the word COVID. But yeah, the thing is that this is like a fairly long sentence if you look at it, and it also has some scientific terms. So this was one example that I was going to go with. And again, I'm happy to take any examples from the audience to see if you have any complex inputs that the model is able to perform or not able to perform. So essentially what we do here is we have abstracted the code of basically fair sequence commands from the user end, and we've created some simple bash scripts where you have to just give your input file, the name of the output file, your source language, your target language that you want, and the model directory. So these are just the things that you can understand and see. So you don't have to do a lot of heavy lifting that's happening on the back end. and that way we try to make this adoption easier. But again, the reason why I'm showing you code is that so tech people can always go over, look at the code, see what is happening, and change something if you want to get better performance, or run something on your own as well. So okay, this is finally running. We have these 3 examples. So once this finishes, or yeah, I'm just happy to take more examples and we can keep working on this. And yeah, you feel free to run the same on Ulka, or if you have any examples, you can use it on your phone as well. So open Ulka and start trying out examples. If something works, you can tell us that it's working well. If something doesn't work, you can again tell us that it's not working, you should improve here. We're happy to take both feedback. Right. If you see here, right, so the first sentence is, this bicycle is too small for you. And I did it to English Telugu because I read Telugu, and I'm guessing somebody from the audience also reads Telugu, and I want to make sure that this is correct. Yeah. So, right. So the third one also, I'll scroll over and you can see the whole thing. But if you, I want you to look at the fact that it got COVID-19 correctly, and it also capitalized, given that it's understood that it's a scientific term. I can show you some other examples as well. So when we were working on doing some translations on NPTEL content, so we passed it inputs with words like vector, something like integration, differentiation. So, and we were checking if it's able to get these words correctly. The very interesting thing was the model was able to give a correct scientific translation for the word differentiation in Telugu, but also write in brackets the transliteration of differentiation. So that's something that a model is able to learn. And why it learns is a question that we're still trying to answer ourselves. How it learns, that's also a question that we're trying to answer ourselves. But the interesting fact is that it's able to learn. Yeah. Okay, this is the training script of basically once we have the binary file ready. So the binary file goes into this. This is where the final bin, that is what the previous script generates. And once you have that, we have a bunch of arguments here. Basically the size of input text, output text, number of steps you want to train for. I put it 1000 so that we could finish it off now. And saving interval is basically how many checkpoints you want to save. Architecture is something, so in our architecture is 400 million parameters. So we defined our own architecture based on whatever things that we've been studying. So we call it transformer 4x. And you have the loss function, the learning rate schedule. This is more of the technical content. These are fairly straightforward for more of most deep learning things. Nothing fancy here. It's mostly the same thing. And here we use a number of GPUs as one for the demo model. But when we were training it on 8 GPUs because this requires fairly large amount of compute to train it for the first time. So that's where open sourcing these models and then letting others fine tune, where you require fairly less number of compute and less number of training steps to adapt to a particular domain. That's where open sourcing these models come into play. That is this notebook. We can quickly go and show the fine tuning as well. So we have text inputs, right? So we have converted them into Devanagari. We have tokenized them based using a tokenizer that we built. So after tokenizing, these are basically numbers. We zip it in the form that model requires. So these are instead of passing text file directly to the model expects a binary file so that it can read and write efficiently. That's the whole thing. It's basically a fancy of zipping content, that's it. That you pass to the model as the input and it will train on top of it. Yeah, we have another notebook here where you can fine tune on top of ours. So if you go to the fine tuning section here, which is available again on the README, we have a collab notebook there. The instructions here are also fairly common to what we have seen. So one is we again install all these libraries that are required to do the fine tuning. Again, install fair sequence. Once we have that, this is where we download some data and we download the existing checkpoint, the model that we released. Then when you download this model, you also get files called these dictionary files, which are created while building the vocabulary. So you need to use these files and then tokenize the new data that you want to create. So that way you can add that data directly in the format that the model has already seen, and you should be able to run the same training script that you have shown before. So This is all the pre-processing steps that I've been talking about. So we have commented everything, what each function does, everything is here. In the interest of time, I'm just going it very fast. These are just some reorganization of how things happen. And again, we land at the same function where we do fair sequence train and pass in a binary file, get the model training with the help of the existing weights and train on top of it. So when you're doing fine tuning, you don't have to do it for longer amount of time and you don't require a lot of compute. So you can do fairly less number of steps, and given a small amount of data, do update the model for a few thousand steps, and it should be able to adapt to the new domain data that we have. Yeah. So this is what I wanted to show. I can take some questions, or and also we can meet offline for the script conversion thing, and we can talk about that.